What is the real reason behind finding mathematics as a difficult subject? What is the reason that you find mathematics is not meant for you, or you really cannot do mathematics, and mathematics is something which is not your cup of tea, and A, B, C, D, different types of issues? Now, fear for mathematics or finding mathematics as a difficult subject or taking up mathematics not as a career is not common only to you, but if you look around your friends, people, colleagues, etc., this is a common thing that I cannot do mathematics or my brain is not used to do mathematical problems. What could be the reason? Well, I'm sure it is not that you do not understand mathematics, you're not a smart guy. It is not that you don't know the formula. It is also not that you really cannot do mathematics because you don't have the outlook or you don't possess a critical thinking. Nothing. I can promise you, you can do mathematics. It is simple and you do have the outlook much better than me. These are not the reason of finding mathematics is a difficult subject, but the reason is this one, as you can see on the screen, which I have called this as translation. Now, you might be thinking that what do you mean by translation? Translation can be from different language like Spanish, German, but yes, I can tell you that I would be speaking and talking about this central idea, this central problem, and I'm sure by the end of this video, if you watch it, you will be a smarter person to do mathematics. You will do mathematics much better, and you can take up career in mathematics, physics, or whatsoever. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to this fresh video. What could be the real reason and what is the single reason finding mathematics as a too difficult subject? Watch the video till the end. The answer will be in front of you. Can see right on the screen that the basic problem of unable to do mathematics or finding mathematics as a very difficult subject is what is called translation. Now, right on the screen, as you can see, that our brain is tuned or wired to find a cup as a cup, or as a chair, or a cat or a dolphin or any other subject. And you can see that I have written what is called a certainty. Now, what I'm trying to make a point out of this is that whenever we perceive something in our daily life or in our nature, we close our eyes, or when we can see those things, we try to assign an image particularly of that subject. Now, right at this moment, it's early morning, I'm sick sounds. Now, we cannot hear all those sounds, but we can assign a mental image to that particular object. It can be a car honking, it can be a bird, it can be some child shouting, or anything. There is a mental image which is attached to that particular sound or a particular perception, and we try to imagine that perception in our mind. Now, while doing mathematics, for example, or maybe physics, when we are learning a particular concept, it can be anything. It can be acceleration, velocity, gravity, any further concepts like wave functions, etc. We always try to compare that particular concept with our daily life. I will definitely give you certain examples, and the problem is that when that comparison is not matching with our calculation, or when we are going with further studies, we face a problem. So that is why I have written right on your screen that the problem arises when you try to compare, when you try to find an analogy of that particular mathematical concept with our daily life. It can be cars, people, birds, sky, apple falling, or a car speeding, etc. The problem is that when we try to make an analogy and then when we try to think about that, we really do not find that things are not matching. Now, this is the central idea, that comparison, or I would say translating that mathematical concept into something. Say for example, we say that, okay, so can you imagine something like a big star or a big planet, and the planet is contracting. So you try to imagine a kind of a planet or an object which is contracting, or let us say, or in your mental thought, you try to imagine something which is expanding, maybe a balloon or something. Now, it is good to have analogies right at the beginning, but in mathematics, what happens? This type of analogy, when you further do the calculation, that expansion or that contraction, or the person or the apple falling or an object speeding at the speed of light, really cannot match with the calculations. So what happens is that when the calculations are not matching, or when you are thinking that this is something which I perceive, but my mathematical calculations on the paper or the further proceedings of mathematics are not matching, then what is happening? Because our mind, our brain is wired to think certain things and absolutely certain. So if it is a bird, then it would be this kind of a shape. If it is a car, it would be this kind of a shape. It is the speed of a train, it is this kind of a shape. But as you know, the world of mathematics and the world of physics is also something abstract. So certain things which we think in our mind as a direct perception or the shape of an object never matches with our calculations. And when it doesn't match, we find that mathematics is difficult, we are unable to solve. Why? Because that perception or that shape or the way that particular object will behave is not matching with the calculations that we are doing. Let me give you some quick examples. Things will become clear. The first example which we do in daily life, in everyday I mean to say, this is starting from school level mathematics. When we start with vectors, what first comes to your mind? Tell me honestly. These are arrows. These are arrows pointing in this way, that way, up and down, etc. Again, I'm saying that analogy is not always bad. But remember that vectors are not always arrows. As we move up the ladder, as we move into more abstract and advanced mathematics, vectors are, I would say, when I have talked to pure mathematicians, they say, Shaunak, vectors are not arrows to us. Right on the screen, as you can see, vectors are elements within a mathematical structure which is called a vector space. This space defines different properties, but it does not specify how a vector look. That means it is a member of a vector space, and that vector space has got certain properties like addition, multiplication, whatever it, but it never defines vector that it should be this or it should be this. That means the concept of that arrow is no more there. Now, what if the teacher, or what if you start imagining always vector as it should be arrow? Yes, I understand there is a adding method from tip to tail, etc. There is an extension, magnitude, etc. for vectors, but it is always not arrows. Now, when this concept, as I was telling, a car or a train or a bird, etc., when this concept is not matching with the mathematical calculation, what happens? You find mathematics as a very difficult subject, isn't it? So as you can see, that vector space is not arrows. These are abstract objects where those arrows really don't come into play. Right on the screen, as you can see, that in mathematics, a vector is defined as an element of vector space which has got certain algebraic properties, and you can see I have written in red that these properties are sufficient to define vectors without the need for a geometric representation. That means vector space, we need to understand it is something which is an abstract object, and this gives the quality or an object to qualify as a vector. We really don't need those geometric expressions. So this actually again shows that vectors are not arrows, and if you're imagining vectors as always to be arrows, when it really does not match up with the mathematics, you find vectors to be a difficult subject. So here is a very important point, that arrows are used for visual aids. So the familiar arrow is a convenient way to visualize vector in 2 or 3 dimension, but this is a visual representation, remember, not the actual definition. So once we were doing vector calculus, etc., you will see obviously vectors are absolutely not arrows. When we move up the ladder or the direction of north, or it is going in this direction, your imagination is just arrow. An arrow which has got a tail, which has got a tip, and it is going in an area. And if you start training your mind in that abstractness, you will never find mathematics something difficult. So translation, thinking them, or drawing analogy to daily life really doesn't work. Also, you can see on the screen that in quantum mechanics, vectors are known as state vectors, and it represents the quantum system. What is a state vector? You all know. And in a quantum state vector, there is hardly any geometric representation. So that actually shows that how vectors are behaving are not mental representation of arrows. It cannot be. So here is something. In advanced mathematics, the emphasis is often on the properties of algebraic structures, not with the geometric representation. Yes, that is very true, because we need to understand what the algebraic properties are, not what this will be north, it will be south, or so on. So this allows for the generalization of vector concepts into more abstract developments, and these abstract developments actually generalize a concept into anything. Now, same thing happens, with differential geometry and topology. So geometry, always a shape, either a triangle or a sphere, etc. Now, that is good in terms of Euclidean geometry, etc. But the moment you move up the ladder, for example, if you're moving into topology classes, as I have tried to show topology with some clay structures in this channel, Physics for Student, but it is actually not. So again, that concept that this would be like a pyramid or like a sphere or a box, that doesn't really work out. So this is the first example which shows translation is a very big problem. Thinking vectors just to be mental images of arrows pointing in this way, that way, really does not work out, because vectors are not arrows but something very abstract, and you need to think in that abstract space so that you really don't find mathematics to be a big problem. Now, this is one example. Let me show you another very daily life's example of mathematics, which is again a problem of translation. Well, here you can see right on the screen the concept of negative. Now, tell me honestly, whenever we hear the concept of negative, what comes in our mind? Right on the screen, as you can see, a negative actually does not in math necessarily mean something kind of an absence, like a negative bank balance, etc. It can represent direction, or it can be an opposite of the operations, that is subtraction, multiplication, etc. Now, I can tell you this much, that for school students or those who are training your mind in order to become a better mathematician or a physicist, whenever the concept of negative arises, what do we think? That it is something empty, something which is not correct, something which is out of the convention in which positive thing flows. But negative in mathematics is again a concept which is, which can just be the opposite. It can also be that in a quadrant system, in a Cartesian or a non-Cartesian coordinate system, we are thinking negative as something, maybe a kind of a direction. So again, a kind of a translation of what you think mathematically negative as something which is we compare to our daily life. So it is a negative bank balance, or my friend, things are going negative. It is always something which is not good, something which is insufficient, something which is blank. But in mathematics, the concept of negative is not like that. It can be a direction, it can be anything, it can be a different kind of an operation which might result into something positive. Right, negative energy, etc. In physics also, you will find certain concept which really does not match with what we think as negative. Again, a translation of the mental image. So this is also an example. Coming up next, a very simple example which I'm sure you're using right now on a pen and a paper. Let us see what does it mean in the next. You can see the equation, the general equations. It can be polynomial or a very simple equation, y equals to x. And what we see, there is a left hand side of the equation and there is right hand side. Now you see, in general, when we were taught mathematics, or when you are also teaching mathematics to your children, you generally try to see equation as a seesaw. So right on the screen, balancing a seesaw might be used in explaining equations. However, this analogy breaks down with more complex equation and more multiple variables. So you see there is a left hand side and right hand side, and you teach, or you give a perception that there is an input and an output, or something like cooking a kind of a cake where you put certain flowers and ingredients inside the machine and it would result into a delicious cake. So equations are something like that, where there's an input and an output. Now it is again a kind of a mental image which might come as a derogatory factor when you're dealing with complex equations, multiple variables, etc. Now I again am saying that analogy is not bad, but the problem is that these analogies becomes ingrained in our mind, becomes a kind of a left hand, I would say, our perception, our idea, our instincts, they become our instincts, and it is very difficult to get out of that. So when you are dealing with equations, which is not a seesaw, which is not a kind of a cooking machine, which is not that there will be some output, input, and then there is output given, then again the question is translation. The question of translation is that you are unable to match up with that picture. You are unable to match up with the perception that, okay, so again, if I am giving two inputs, what is coming, but the output are many. So again, see translation. So translation again means that that picture of a seesaw machine is not matching with what is happening right now. So it is better that we understand equation as equation, not as something which will immediately give a kind of a stereotyped mental image, and that happens when we are translating. Another very quick example, which is very interesting, I'm sure you're going to enjoy, coming up into the next part of the video. Flipping of the coin. Now, this might have been given by your tutor, or you might have thought in terms of probability or stochastic learning that this is something which is definitely going to happen. That means what? Sometimes you flip a coin and the probability explained with the outcomes of the coin, so you really don't know what would be head and tail. That is fine, but again, is this something you're trying to translate? If you're trying to translate, you're making a mistake. Why? Because flipping of the coin only occurs or only happens in case of discrete probabilities. What about this? This analogy only works for simple discrete probabilities, but when you get something which is a continuous probability or something which has got a finite set of outcomes, it really doesn't happen. It really doesn't occur. That means that mental image of tossing the coin and it is falling on your palm or something, which will either get a head or a tail, or not a dynamical system, because from head you can go to head. Even I have shown into my multiple videos of quantum physics, etc. Again, the problem is translation. The mental image of flipping a coin is ingrained in your brain, that whenever we are talking of probabilities or outcomes of a system, you will always think that it is a coin. And when it is not a coin, or a kind of a, when I talk of a continuous probability, that mental image is disturbed. And whenever it is disturbed, we try to feel bad. We feel bad. And this feeling bad translates as mathematics is not my cup of tea. A very quick example will further elucidate the factor, coming up into the next part. Often in the classes of calculus or derivatives, we are always given this analogy, or as a teacher, you might be teaching the slope of a hill and a derivative. So a student, right on the screen, I have given an example that a student struggling with derivatives might be told to think that it is a kind of a slope of a hill, but it will not resonate with everyone who cannot feel this concept, that I really do not get it, if they cannot grasp that analogy. So that is why I have written on the screen, you can see that the slope of a hill represents a static change, the overall steepness at a particular point, but derivatives are not that. There are instantaneous changes, the rate of change at an exact moment of time. Again, a translation. Now, when derivatives is not that it will be very discrete and you're coming down the hill, it's an instantaneous change. So that means, again, if you're trying to translate the concept that, okay, derivatives, I'm coming down a hill, there is a delta x and there is a delta y factor, again, that would create a problem. And when you're doing calculus, when you're learning derivatives, that is a mental translation which you always do with derivatives, and you get stuck up. Because this is not the exact right approach, that is not the way in which derivatives happen. See on the screen that if imagine that there is a curvy road and the slope might change constantly even though the overall path goes uphill. So the derivative captures the continuous change, not just the final shape. So the slope of the hill considers change in one direction, up or down, but derivatives can be applied into multiple directions, and it can be also taken into multiple dimensions. What happens that? What happens when you're taking multiple variables, or what happens when you're dealing with different directions? So the concept of that hill again fails. Why? Because you're trying to translate that mental image with another further advanced calculations of derivatives which are not happening. So this is something which I just showed you in few examples. These are the problems that you happen in mathematics when you try to translate. The problem is that that translation or that analogy gets so much definitely ingrained in your brain that you cannot come up. And that is a problem. That is a mental image problem. Psychologists tell that once it is put in your mind, it is very difficult to unwind. And that is why in advanced classes of mentoring, we call that you need to unwind and unlearn a lot of things in order to learn these things. It is very difficult to unwind and unlearn. So these are the problems. Now we will come to the solution part, that how you can do that, coming up into the next part of the video. So first of all, I would like to share one of my personal experience which used to happen in our days when we are at ashrams, and it is just basically concentration. So when the Maharajas and the Gurus are sitting in front and we were asked to close our eyes. So close your eyes, and what we were taught is that you have to listen. You have to listen to each and every sound which is happening around nature. So it is not that concentration means that you really close your eyes and you do not listen and just only chant any mantra or something. No, you need to listen. But the thing is that when you're listening, for example, right now, early morning, the birds are chirping or the cars are honking or anything which is happening, do not assign that sound with the mental image. That was the first idea of dhyana or concentration in the days which used to happen in ashrams, when the Maharajas, or I would say even the brahmacharis, used to say it, that you need to listen, but you cannot assign that sound with a particular image. I remember that famous line which is from Ashtavakra Gita. I just wanted to share something with you. So right on the screen you can see that it is called Sakaram Anritang Vidhi Nirakarang tu Nishchalam Etatva Upadeshena Punarbhavana Sambhava. So it is from Ashtavakra Gita. So what it says, Sakaram Anritang Vidhi. Sakar, that means that which has got a shape. That means it is a akar, that means a shape. Anritang vidhi, that means it is not nritang, that means anritang, it is impermanent. I mean to say it is spiritual, but in way you can lead it to mathematics, that again when you are translating things to a form, it is anritang, it is not permanent, it is not the truth. So sakar is anritang, nirakarang tu nishchalam. Nirakar means that which has not got a shape. That means abstract space, abstract mathematics, anything like that. A tattva upadeshana punarbhavana sambhava. That means once you know this upadesh, or when you know this fact, then you get enlightenment. Anyway, we can discard that enlightenment part, but we are trying to get ourselves enlightened in the area of mathematics. So Sakaram anritang vidhi narakarang tu nishchalam. So we were taught during the days of ashrams, long concentration, dhyana, etc., that do not try to assign anything with the mental image, because mental image, when it comes, it creates a problem in concentration. I remember the famous philosopher Alan Watts. If you can go to internet and search, he has got great talks. Alan Watts, he also told the same thing, that do not assign anything with the mental image. So in mathematics also, please do not try to assign that with a kind of a translation or daily life. Mathematics doesn't really always happens translating things into daily life. Coming up into the next, I will just tell you what are the points that would help you not translating and do a better mathematics. So coming up, we need to move beyond the analogy in maths and physics. So first point, as you can see, is that focus on core principles. Emphasize the underlying mathematical definitions, operations, and relationships within the subject. So what is the main principle? Vector? Okay, these are members of vector space. What is a vector space? This has got algebraic properties, etc. When we were talking of maybe probabilities, so it is a definite outcome of a system. It can be this and that. It is not flipping of the coin. Okay, so this is a term which is negative in mathematics. So it is not which is mathematical in nature. So we need to understand that. Right in the screen, you can see, understand the concept as it is. Please do not draw analogies, mathematics has its own world. Yes. Now, I have talked in one of my videos that mathematics is a language. I don't want to go further into that kind of an idea. But yes, you need to understand that just like we are translating things around our daily life, when we're going to college, when I'm delivering lecture, when I'm doing a little bit of concentration, dhyana, etc., whatever I'm doing, what I'm trying to do is that this is a world around us, this beautiful world, and in this world we have got certain concepts, certain ideas, certain thoughts, and we are trying to understand that language, understand the society, etc. So let us consider that mathematics also is a kind of a language. It is also kind of a world, but it is a world of its own. You cannot compare that world with always something similar to what is happening right now. So what I would say is that mathematics has its own world, and I've put it in this way: it has its own society, people, and a definite set of rules. So let us get used to this language. Let us get used to those culture of mathematics. So that this is a different world. I mean to say, how can you say, even if I use a kind of a foreign language, Spanish or German or French line, and if you ask me that, Shaunak, you do translate it in English, it is not always possible. Because that language has its own beauty, that language has its own perception, that language has got its own way of expressing a thought, and that thought cannot be expressed always into this language. So that is why translations from different languages and reading poetries, etc., I mean to say, you can do it, but it really loses the essence of that particular thing. And lastly, there are a few points that please do understand the function as a function, derivative as derivatives, eigenvectors as it is. Understand the definitions, and it has got no analogies. Remember, it has absolutely got no analogies. Only thing is that when we are training our mind right from the childhood, etc., we are given those analogies. I can tell you that I remember anyway, it would be a little bit spiritual in nature. Even we are thinking of attaining spiritual enlightenment, etc., also you're given a sakar, that is a form, and then from that form you motivate yourself and get into something which is formless. So it has no something like you can imagine something to be, or you can think it to be so. So it is nothing like that. It is the world. It has got its own science, it has got its own language, society, people, culture, and so. And we need to understand that, and we have to stop translating things into our daily perception, and that is how we can come to know. And today's video, I hope you liked it. This is something which has been going in my mind, that I should make a video, because there are a lot of videos and there are a lot of students who comes to me, subscribers, otherwise in colleges, etc., that I cannot do mathematics. Mathematics is not my cup of tea. What could be the definite way of doing mathematics? Something like that. So I would say it is not that you really don't know mathematics. You know much better than me. You know functions, you know variables, you can do mental maths, you have got the perception, and in today's internet and AI world, things are much easier. I mean to say, when in our days we really have to go and search into the library, sit for hours, or wait for the professors to explain. You can just type and Google gives the answer to the entire world. So these are not the problems. You can do much better mathematics. You are a much smarter person than me, I can assure you. But the problem of mathematics is translation. Every moment, whatever we learn, we try to draw an analogy and we try to find out something which will match in our daily life. So I can tell you, all those who are watching, my dear friends, sisters and brothers, and anyone who is out there, that it is not translation. Because you cannot always translate. Similar to a language, you cannot always translate to your mother language and find out the essence. Yes, you can, but it actually destroys the beauty, and so it does in terms of mathematics. After all, mathematics is a beautiful subject. It has got a beauty of its own, and translating this not only destroys the beauty, but makes you think that, oh, mathematics is not my cup of tea. Analogies again are good. Analogies are good for learning, but these analogies should not be so permanent, ingrained in your brain, that you cannot get out. And whenever these translations or these thoughts are not matching with the calculations, you find mathematics is a difficult subject. Why? Because our mental thought, our mind is actually tuned that everything should match with our daily life or a mental thought. No, it is a different world. Let us get into this world, make friends, and know the society. That's all for today's video. Thank you for watching. Please do let me know whether you're finding this video to be good and whether you have stopping translating and think mathematics as a language or as a word and think things to be. Physics for Students will be soon back with many more interesting videos and some very important podcasts coming up soon. Stay tuned and do not forget to subscribe to my channel. Click on the bell icon and get all the notification from Physics for Students. Thank you very much. This is Shaunak signing off, promising you to be back with few more videos. But for the meantime, stop translating and think mathematics as it is. Thank you very much.